Okay, so in the previous video, we talked about finding the domain of polynomial equations or polynomial functions. And this time we're going to talk about finding the domain of rational equations. By definition, rational equations are equations with variables in the denominator. So these are the fractional equations. For example, we have f of x is equal to 5x minus 6 over x minus 4. Okay, because we have a fraction and there's a variable in the denominator, we gotta be careful. We're gonna need to be very careful when finding the domain or, the values that will give us still a real number, value. Okay, so I'm just gonna say that you are to evaluate, f of 4, meaning the value of the function when x is 4. So the tendency is you're going to plug in the 4 to your x. So we have 5 times 4 minus 6 over 4 minus 4. Okay, so what's going to happen in the denominator is we're going to have 4 minus 4, which is 0. So let's evaluate the top. That will be 20 minus 6, and 20 minus 6 is 14. So that's 14 over 0. That means my f of 4 is 14 over 0. But what is 14 over 0? Remember, any division by 0 is undefined. So that means we're going to have undefined value when x is 4. And that's the one that we need to avoid when finding the domain. It can't be undefined. So everything has to be real numbers. It can't be, undefined, or it can't be imaginary. So we'll talk about imaginary, number when we get to the rational radical expressions or equations. But for now, when we are when we encounter rational equations, one thing that we want to avoid is having an undefined value. So now we know that, how do we know that we're going to have undefined value at x is equal to 4, So you pretty much can solve your denominator, and your denominator is, because your denominator is x minus 4, you equate that to 0, and so plus 4 to solve for x, we get x is equal to 4. So I know that when I have, okay, so I know that when x is equal to 4, it's going to be undefined. In this case, it's very easy to spot because we only have, a simple expression like x minus 4, but there are um, some instances where this is very important, the equating it by 0. Right now, like I said, we can just spot the value that gives us undefined value because, what makes 0 by subtracting 4 is the positive 4. So we'll take a look at that example in a bit, but for now, um, we're going to say that the domain of this function is all real numbers except, what is that value that we can't take except the positive 4. Now, when it comes to interval notation, or, when expressing that statement, all real numbers except 4 in interval notation, it's gonna be another topic. But to, give you guys an idea, okay, it's gonna be technically writing the interval notation of the real number line that represents our domain. So in this case, if we want all real numbers except 4, and then let's say this is 0, and this is negative 4, and this is positive 4. We want all the numbers, okay, all the numbers in the real number line except for this part right here. So we're going to shade all of these to the left of 4, including the arrow because it's continuous, and to the right of 4, okay, except 4. So now let's go ahead and name those intervals. Okay, so from here up to here, we're gonna say it's from negative infinity up to 4, but 4 is not included, so we're gonna use the parentheses. And infinity is not a number, so we also use parentheses for that. And then we're going to use the conjunction or. We will dig more deeper into that or and or an and. But for now, because we're talking about union of the two intervals or two sets, we're going to use the or. And then we want to also name this interval. So that interval is from 4 up to positive infinity, and 4 is not included, so we're also going to use the parentheses symbol, and for infinity is also parentheses. So the domain is this whole thing. Okay. So if you're asked to find the domain of 5x minus 6 over x minus 4, you're going to say the domain is this interval. Okay, we'll have more example in the next video.